Hello, everyone. Welcome to today's webinar. Today we are talking database DevOps, building better systems. So let's start with a little bit of housekeeping today. There'll be no need to record anything today. We will email you on Friday with a link to the recording on YouTube. We'll have 10 minutes at the end of today's sessions for live Q&A. You can join our Octopus Slack on octopus.com/Slack. If you put your questions into the webinar, alternatively, please use Zoom Q&A. Try not to use the messaging. The main reason for that is sometimes we miss the questions. So today I'm joined by Mr. Alex Yates.
Hey, how's it going?
Not bad, Alex, not bad. What about yourself?
I am getting over a cold, but I'm nearly there. Otherwise good. It's very cold down here at the moment, although I'm down south in warm Cambridge.
I wouldn't call anywhere in the UK warm at the moment. Obviously, you can hear a little bit of me. I as well also have the cold. So I'm really looking forward. Hopefully, this will warm us up a little bit, Alex. So yeah, over to you.
Cool. Well, this is the second part of a two-part series. In the first part, I finished with this slide, and the main point I was trying to make there is if we focus on doing these four things, our life tends to be a bit easier when we're managing databases. So I focused on resilience versus robustness, continuous integration in its truest sense, and loosely coupled systems, both from a human and from a technical perspective. I'm not going to go over any of that now. If you want a recap on any of that, go and rewatch last time's webinar before you come back here. But given those things, how do we go about doing that? That's what I want to talk about today. And today I'm going to talk about three techniques that we can apply that will hopefully help us to move in that direction. As I said last time, it's not going to solve all of your problems and it will pose new ones, but it should in general be a net good and it should help a fair amount. So what are the three things I want to focus on this time? I want to focus on the avoidance of shared databases in the dev domain. I think that as many dev test workflows as possible need to be working on their own dedicated infrastructure that we can spin up and tear down like cattle rather than pets. And there are some techniques that we can use to make that possible in the dev domain for databases, and not enough people are using them. So I want to talk about those. The next thing I'm going to talk about is database deployments. Database deployments are scary because they can be very hard to roll back. So how do we make our database deployments safe so that we can avoid having these terrible database failures? And how can we enable rollbacks in a quick and safe way without having to do a whole bunch of data churning? And finally, apart from provisioning dev databases and deploying production databases, I want to talk about patterns for just breaking up your architecture in general, because a lot of these problems are a lot easier to solve if we have a much smaller, simpler estate, or if the limit of our problems are better scoped. So that's what we're going to focus on today. So let's get started with shared databases. Shared databases are frustrating. They frustrate me so much. Nobody would accept it if a developer said they're going to put all of their .NET source code on a file share and let everybody hack away at it at once. The thing is never going to compile if you've got 100 developers hacking away at the same source code at the same time. So we shouldn't be accepting it for databases either. If each developer is hosting their own database, then yes, they might fail fairly often. But if they can throw it away and respawn it, then they might learn a thing or two about how to break the database and hopefully how not to break the database. One of the things we learned last week is that success at mitigating failure requires experience with failure. So you've got to give your developers the opportunities to break things in a safe environment. Once we move self-service, we've got a huge amount less bureaucracy as well. I don't want to see anybody submitting tickets for a new dev or test environment. I don't want to see any review about whether or not we can afford this thing. Like, if you're concerned about the cost of all of this infrastructure you're spinning up, set up a monthly price cap for whatever you're using for hosting. But don't be micromanaging every individual environment, because just your business does not have the time or the energy for all of that needless bureaucracy. Also, by making all of these environments quick and easy to spawn up and throw away, it means that a whole bunch of things become easier. We can test our stuff in isolation an awful lot better. We can enable true continuous integration, where I'm just taking production plus my changes, merging it back in, and off it goes. And I can enable smaller deployments as well. And all of these things reinforce each other in ways that I discussed last week. With databases, we tend to have two significant problems. The first problem is security. If I've got sensitive data in my database, and most of us do have sensitive data in our databases, data about real people who have real lives that might like that data to be kept private, then we need to figure out how we're going to do this in a way that is responsible. And we also have a practical problem. While it might be easy to spin up a new version of the application on my local machine, if the database is 15 terabytes, I'm not going to be spinning that up on my local machine. And even if I am, even if I've invested in a massive, beefy desktop to run that, it's just going to take a long time to copy across all those bits and bytes. It's not very efficient. So we need to think about how we solve these two problems, and I'm going to tackle them one at a time. The first thing I'll talk about is the security issue, because I think it's really important. I'm in the UK, and I know that geographically where you are, sometimes that people have slightly different opinions about safety, but I'm pretty hot on safety here in the UK. I quite like my data to be kept safe. So the philosophy I want to promote is that everything outside of production needs to be clean. You can't be having production data in there. You can't be having sensitive data in there. You can be having production data, but just not the sensitive stuff. I want to know that if I accidentally leaked my dev database to a popular hacker site, I'm not going to sweat, because I know that there isn't any sensitive data in there. And how can I do that? Well, the first thing I need to do is actually do a data cataloging, data mapping exercise. And that's something you should all be doing anyway. If you fall under GDPR or any similar legislation, you should already be making sure you know where your data is and how you keep it safe. For all of the sensitive data, we want to be setting up masking routines, and we want to be able to run those on a regular basis. So behind the production firewall, somewhere safe, we can create a copy on a reasonably frequent basis of production. It's a good idea to be testing your backups anyway. Not only a good idea, it's like important best practice, because you're not as good as your last backup. You're only as good as your last good backup, and you only know it's a good backup by actually restoring it. So on a frequent basis, you want to be restoring your most recent backup, running your masking routines on it. So you've created a dev safe, if you like, copy of the database in the production domain. Once you've got that, you can make a copy of it available in the dev domain, from which all the developers can spawn their new dev databases. Now, that might be as simple as placing a known good backup on a file share somewhere in the dev domain, but you might want to go a step further than that. Because backups, as I say, they're full fat. That's going to be an awful lot of bits and bytes that we're moving around. How we could make it a bit easier on ourselves by looking at the various virtualization technologies that are built into our operating systems. If you're running on Windows, we're talking about setting up virtual hard drives and creating differencing disks against them. That's kind of a thin copy. It's basically just a pointer. I'm tricking my local system into thinking that it's running the same version of the code that's on the remote system, and any changes are stored locally, which gives me the experience of having a full fat database on my workstation. Even if I only have a kind of standard size hard drive, this works up to 64 terabytes. So I can trick Windows, I can trick my database engine into thinking that 64 terabytes of data is running on my local machine when it's not really. What that means is I can get reliable, realistic performance from my database engine in terms of query plans and everything. I do obviously want to make sure that the network latency between my clone and my VHD is nice and short, because that thing can hit your network. If you're remote working at the moment, for example, don't be building these clones on your local system and then using kind of public internet to get there. Make sure that these clones are living nice and close to the virtual hard drive itself. But the magic thing about this is you can create the illusion that you're creating copies of 64 terabyte databases in seconds. So as long as your databases are under 64 terabytes, this is potentially a really nice solution for you that enables your developers to spin up dev test copies almost instantly with masked production data. We can also add into, when we're preparing the dev copy in the production domain, we can also add in known test cases and stuff as well, so that we've both got realistic data and some known test cases in there. So that all sounds great in theory. Let's see it in practice, shall we? So there are various tools we could use for this. There are open source tools called DBA Clone. Redgate has got a product called SQL Clone or SQL Provision. But this is another thing that they've produced called Spawn. It's a fully hosted version of that sort of technology where I can spin up a container in the cloud containing a data image, if you like, of data, and it takes seconds, and it allows me to instantly have access to large data sets. So, for example, if I go to resources, you can see the Stack Overflow database. This is a SQL Server image running on Ubuntu. I can build one for myself. I can give it a name. I can give it an expiry time if I want it to auto-delete itself. And this is going to spin up an instance, a SQL instance for me in a container. Is going to load that database as a clone into that container. It's going to have the full Stack Overflow database on it. It's 400, 500 megabyte, I think, the best part of a terabyte. And it's going to do all of that in a handful of seconds. It shouldn't take very long at all before I've got this container available, and there it is. Fantastic. So I'm going to so I can now access it. The port is 31667, and the password is a random password like that, and I can connect. Right, here is my database. As I say, it's a full Stack Overflow database. That's 390, about 400 gig worth of data in my Stack Overflow database. And if I look in the users table, for example, we'll see that all the data is there, and I can play with it very easily. And I'm just running this from my local machine. It works really, really nice and fast. However, I like to automate this stuff. So Spawn has a command line tool that you can use to build images and so on. And I can automate it using an Octopus Deploy runbook. So this is Octopus Deploy. This is my runbook. I'm just going to run it quickly. I'm going to kick it off to get it started because it takes a couple of minutes to run. And then once it's running, I will explain what it's doing. So this is running a bunch of automation scripts to build me that container. It's spawning me the new container. It's then going to do a little bit of prep work to set up a few databases for me. It's going to do the initial creation of a couple of demo databases on that container that I'm going to use in a later demo. And it's going to set up a DB-up schema on there. Well, I'll talk about DB-up in a bit. It's also going to update some Octopus Deploy project variables. So if I scroll down, and before I show you that, I'll show you where all the code for this is coming from, because you can do this yourself. All the code is coming from this GitHub repo. I've set up in Octopus Deploy, I've set up GitHub as a package feed. And it's really cool when you do that, because it means I don't need to worry about packaging anymore and making my NuGet packages and sending them over. It literally just reads the public repo. It looks for the tags. I've got various tags. And it just picks the most recent tag and it checks out that code as if it's a NuGet package. So that works really, really well. The code that it's going to run is for Spawn. It's running these three scripts here, and it's just running these scripts as they come without any parameters. So the Spawn data container script, for example, this is what it's doing. It's the important part of this script is basically this stuff up here. This is actually the code that I need to run to spin up the container. The rest of it is just variable handling. After that, it's running the script to set up DB-up, and then it's setting my project variables. What's it doing with variables? Well, if I go into my variables, and there we are, I had previously set up an API key variable. That's because in order to change your variables from a script, you need to use the API, so you need to create an Octopus Deploy API key. But the variables it set up for me are these, my connection strings. These are the connection strings to the databases that have just been created in Spawn. And that runbook has now finished successfully, I believe. There we are. The dev one ran successfully. You can see I've got a broken production one from yesterday when I was still building the demo. Sorry about that. But the development one that I just ran successfully. And if I go into Spawn and do a refresh, if I scroll down, you'll see another data image has been created for me down here. It's called Database DevOps Webinar, Dev Environment. And then I've just taken the ID of the runbook run just so that it had a unique name. And I've got my host and my port and so on over here. So I'm going to, once again, pop that on that side and pop Azure Data Studio on this side so I can connect to it. So let's make a new connection. I want my host. I want my port. The username is going to be SA and the password is there. Let's connect to that. There we go. So this time we've got, I picked an image that had the Wide World Importers Microsoft sample database already inside it. But what I created are these Facebook and Toggles databases, and I'll play with those in a later demo. Before I do that though, first of all, there are no tables there. All I did here was the initial creation, so I still need to deploy those updates. One thing that I did do is I did create a dbup schema. That's the prep work that I was doing, and we'll see more about that in a minute. To actually deploy those though, I need to run a deployment process, which, let's create a new release. And you can see that's picking up the most recent tag from GitHub, and it's going to run a couple of scripts from there. It's going to run the deploy Facebook. I'll show you in GitHub. It's going to run the deploy Facebook and the deploy toggles PowerShell scripts as part of that deployment. Let me just double check. Let's get that triggered. There we are. That's triggered my deployment. So while that's running, I'll show you how it works. So these PowerShell scripts, I explain where my SQL Server scripts are. I provide the connection string that my runbook just set for me when it built my database container. It says I'm going to use the dbup schema, and there's a table called journal in that dbup schema that it's going to use to log all of the scripts. And then I'm just going to load up a couple of dbup DLs that you can download in advance. And then it's going to run dbup to run my various scripts. And the scripts that it's going to run are the scripts that are in here. So you've got my create schema object SQL script and my insert data SQL scripts. So this is a just regular T-SQL that's going to be run to build those databases. So my deployment has succeeded. If I go back into Azure Data Studio and refresh my tables, for example, there we are. I now have a bunch of tables, including a journal table, which will have all the information about the scripts that have been executed and the time and so on. So that is my demo of provisioning a database and running some deployments against it. That was all fairly easy. I could have automated that to run even more instantaneously by automating the deployment to happen straight away. And I could have done that with a very large database. I could have done that with a 64 terabyte database, spin me up a copy based on the latest version of production data with the sensitive data masked out, run my database tool, whatever I decide to use, whether I use dbup or something else, to update the schema to the latest version on mainline and source control. And then I've got a dev environment ready to go that's not too big and doesn't contain any sensitive data, and hopefully doesn't require me to get sign-off from anybody. I can just build it, use it, throw it away. It also works really well in any automated test routines. Rather than maintaining a persistent build instance, for example, I can just spin up the databases as I need them. So that works really well. So fast self-service provisioning helps for a whole bunch of reasons I've just mentioned. It favors resilience over robustness. We're anticipating that stuff is going to go wrong, but when it does go wrong, it only affects one person, and that one person has learned a thing or two about not breaking stuff. It reduces all the bureaucratic coupling, both in terms of asking for environments and getting approval for them, and also in terms of just managing all the different people working on that shared environment together. A lot of the time when you have a limited number of environments, you end up batching changes together to be released in one go because you need to test them as a single entity all in one go. Well, that all goes away if we can spin up environments as we like. It enables us to work in much, much smaller chunks, enabling proper continuous integration, like I discussed last week. Do one thing at a time, keep it small, check it in, push it out. Which enables shorter lead time, which leads to smaller, safer, more frequent releases. So all of the good stuff. We're starting to get virtuous cycles now instead of vicious ones. Cool. So we have built our dev environments, and hopefully we've got off our shared dev environments. Now let's talk about deployments. I want my deployments to be safe. And what I really mean by this is I want to be able to get back to a good state quickly if something goes wrong. I'm not necessarily saying that nothing will ever go wrong. I'm going to try and minimize that. But what I'm really saying is that I'm not going to, if I do break stuff, I can recover from it very, very quickly because I favor mean time to recovery over mean time between failures. So in order to achieve this, there are a few techniques that basically revolve around separating out the deployment of changes and the revealing of those changes or the releasing of those changes to end users. Like I said last time, I'm using a very specific terminology when I'm talking about deployment and release. When I say deploy, I'm talking about physically making changes in production. And when I say release, I'm talking about exposing those changes to my end users. And the key point is those two things don't have to happen at the same time. I can deploy my stuff in advance. I can test it in the background. And then by the time I reveal it to my end users, I already know it's working. And if it wasn't working, then I've had a chance to kind of turn it off in the background before it hurts anybody. And from an application perspective, there are various different patterns for this. Blue-green deployments, for example, canary deployments, cluster immune systems. These are all clever load balancing tricks where they basically revolve around having some old infrastructure over here and some new infrastructure over here and pointing my load balancer at whichever servers I want to direct my traffic either the old version or the new version. Application-based stuff is less to do with spinning up different servers and infrastructure as code and load balancing, and it's more to do with managing application and config tables. So I'm thinking about things like feature flags, which enable dark launching. And so I'm going to give you a demo now of how we can dark launch some new functionality in the database without necessarily having to mess around with environment-based release patterns, because persistent database, right? If I've got a persistent database, I don't want to be tearing it down and throwing it around all over the place. I want to leave it where it is, but I want to be able to toggle the performance of that data. So I'm now going to talk about a Facebook case study that was mentioned in the DevOps Handbook, which is one of my favorite DevOps books. In the early days of Facebook, they wanted to implement an instant messaging feature, IM, and they were really concerned about the performance because this was a problem that didn't scale nicely. What they wanted to do is when people logged onto Facebook, you want to see in the bottom right corner who was online right now, and they wanted to show so that you could send them instant messages. And just that showing who is who online, like I say, it's a problem that didn't scale well. So they're really nervous about just rolling it out and hoping for the best. What they wanted to do was do all of that computation in the background long before they released it, so that they had the opportunity to kind of throttle up how much of it they were doing and how much of it they weren't doing. For example, if they just expose it to 1% of users, do their servers fall over? If they expose it to 2% of users in the background, do their servers roll over? What about 10%, 50%, and so on? So by the time it came to release day, they could just flip a switch and they were confident that their servers could handle it. So let's jump back into our demo. And for this, we're just going to be in Azure Data Studio. And let's see if we can mimic that behavior. And let's look at the techniques that we're going to use to do that. So we've got a relationships table, which has got a bunch of people. Let's start with the users table. We've got a users table, which has got a bunch of people in it. And then we've got that relationship table, which is just a whole bunch of relationships between different people. I've also got a stored procedure, which is friends of. So I can run, for example, exec ebo.friends of 34, for example, to take a look at all of the friends of user number 34. All very well and good. What I want to do now is I want to add their names, because it's all very well and good saying that user number 68 is online, but I want to know who user 68 is as a user. I want to know whether it's Bill or Bob or whatever. I don't want to, I want to know who that is. So I also have a feature toggles table, because what I've done is I have already actually deployed both versions of this code. At the moment, I'm running the old version of the code, but what I'm doing in that code is I'm calling out to this feature toggles table. So at the moment, it's not enabled. I could enable it if I want to, just by pressing this button, just by making this one change. And if I run it again, this time we'll see, oh dear, it's running slowly that time. It took a lot longer to run that time. I mean, I've got all the data I wanted, but it took a really long time to run. So let's turn that back off again. If I want to, by the way, I could dark launch it. So let's dark launch it, and we'll see that we'll get the slow behavior. So we've got all the slow behavior because we're running all of that computation in the background. But from a user perspective, they're not seeing it. I could also throttle it if I wanted to. So I could, for example, run it in the background 50% of the time at random. So I could, that's clearly got the old version because it's taking a long time. That's got the old version again. If I keep doing this long enough, eventually it's a roll of the dice each time. There we are, that was quick. So sometimes it's going quick, sometimes it's going slow because I've throttled it. So this allows me to understand what the performance implications are before I actually release it. And I could just throttle it to 1% or 2%, where I'm thinking about resilience. I'm thinking about minimizing the effect of a bad deployment, monitoring it, really understanding it before I actually enable it. Well, let's take a look at how I wrote that stored procedure to enable this. So let's script this as an alter. I'm going to go through this fairly quickly, so I'm just going to highlight. All of this code up here is just calling to the live buttons table and just querying it to find out whether or not the code is enabled or not. So we'll skip over all of that for now. Here is the meat of it. We have the original SQL. So this is the old version of the code saved as just a regular string. And here's the new version of the code saved as another string. And I'm basically going to run this as dynamic SQL. So I've got a whole bunch of steps down here that say if, for example, if it's enabled and I'm dark launching, then run this script, otherwise run this script and reveal the appropriate data. So I've put up a whole bunch of scaffolding in this stored procedure to basically say, based on a toggle somewhere else, am I going to run the old code or the new code? By the way, let's see if we can figure out the performance issue. The eagle-eyed SQL Server geeks among you may have noticed that I'm using a cursor, which is every DBA's favorite friend. And I've introduced into that cursor a wait for delay of a few fractions of a second. So let's take out that delay, because I think that's probably what was causing the problem. And now if I go back to my feature table and re-enable that feature, let's enable it again this time. Right, now it's enabled, I think. Finish spinning. Now if I rerun, where was it? There it was. Now if I rerun this, hopefully, it's still dark launching. For some reason, my Azure Data Studio is being a bit slow with me at the moment, but I think you get the point. that I've fixed a performance issue, I can now turn it on and I can enable it. And that's going to give me a release I can be really confident about because I've already been running it in the background for a long time. And I know that I've fixed the issue. So I'm going to hop back to slides at this point. So that's all very well and good for stuff that runs in stored procedures and stuff. And a lot of the time, that's where we hit our performance issues, queries that are running in stored procedures or wherever else. And we spend a lot of time trying to optimize that and being able to optimize that in production in a safe way, where we can always come back a step just by flipping a simple switch somewhere. That's really useful. But what we really care about with databases is where we're changing the schema of the database itself, changing the tables. So I'm going to go through this one in slides, because it might be a bit easier to follow than jumping through Azure Data Studio. So our goal is to split this column. We want to anticipate that errors may occur. And at every single point in the process, we want to be able to enable a fast rollback. And this is basically going to be, these sorts of changes basically happen thanks to we need to embrace the expand contract pattern, where basically we always allow one level of backward compatibility. And if you want to learn more about this in more detail, check out Refactoring Databases by Pramod Sotalaj and Scott Ambler. So we've got this full name column. The first thing we're going to do is create two new columns, a first name and a last name column. That doesn't pose a huge amount of risk. Those columns can sit there in the background, and the front-end services don't need to know anything about it. It's unlikely we're going to cause any problems at this point. We've not broken any functionality. The next thing we can do is pull the data across. Now, sometimes that's easy, sometimes it's hard. Not all names follow nice, simple Western conventions. What do you do with middle names, et cetera, et cetera? So we need to figure out how to do that, but we've got smart people. We can figure out how to do that, and we can drip feed that in the background. So that at no one point am I overloading my servers with a horrible, with a huge amount of number crunching that's going to spike the various resources of my SQL Server instance. At this point, I need to roll everything out. So now that I've got both the old version and the new version, maybe I've got some application or something that's designed to keep everything in sync. Maybe all of the applications that are updating this need to try and make sure they're updating in both places. We need to figure that out, but eventually we need to roll all the applications over to using the new columns. And to a certain extent, that's not a database problem. That's other stuff that's calling it a problem. But we want to be really clear about the fact that we are going to be deleting this full name column. This is going to go. And the first thing we should do probably is a soft delete. So rather than actually deleting it, let's just rename it. That's going to break it enough that anybody that is still consuming it is going to have problems. So when we do this, let's sit close to the phone and see who rings. But if nobody's rung the phone for a month or so, then they shouldn't necessarily reasonably expect it to us to be able to immediately bring everything back straight away. The other thing I'd say is rather than just putting to delete, stick a date in there, because a lot of the time you see databases with objects that are appended with to delete littered all over the place, and it's ugly and not very nice to work with. So stick in a date scheduled for deletion, and then actually do schedule it for deletion. Have some sort of application or something that just crawls around your database looking for objects called scheduled for delete and with the appropriate date, and do delete them. And then hopefully we're left. And the key thing here is that at every single point, it was easy to revert. Possibly not the last one where we actually did delete it. We backed it up, archived it off somewhere. That might take a little while to restore. But by the time we've got to this point, we're really confident that nothing is immediately going to break when we do that. And yeah, at no point did we create a huge amount of risk. At every single point, we did this kind of in a gradual way, a whole bunch of small steps. And what's more, I keep hopping back to small, safe releases. If I'm only allowed to release once a quarter in a big bang release, this is all happening at once, because I'm not going to wait. I mean, I took 3 or 4 steps here. I'm not going to take a year to make a single column change. Whereas if I can release multiple times a day, then I can release each one of these scripts independently, check everything is still okay, check everything is online. Maybe I'll wait. Maybe I'll wait a week before taking the next step, just to make sure people have had a chance to spot any issues, maybe I'll do it straight away, but depending on the sort of change I've made. But the point is I can make these changes quickly and easily, and I can revert each one of them as I go. So we've talked now about making sure that we can provision development databases on an individual basis quickly and easily. And we've talked about designing for safe deployments. Finally, I'm going to talk about breaking down that monolith, because both of the problems above get an awful lot easier if we have smaller databases and if our database dependencies are significantly fewer. It is going to help everything if we can move away from that dependency nightmare that I described at the beginning of the last webinar. So I've basically just drawn spaghetti on the PowerPoint at this point. Imagine your own tangled web of dependencies. This is actually, if it was actually just this, it would probably be fine. But I'm imagining in a realistic example, we might actually have many times more levels of complexity going on in most real world systems. You've got databases going all over the place. You've got database to database dependencies. You've got apps that are all dependent on each other. Each of the database isn't really sure. And there are a whole bunch of other applications that are just calling into this monolithic thing. And we're not really sure what's going on with everything. When I say app here, by the way, maybe these are separate apps. Maybe these are just submodules of some larger modular monolith. I'm not being too specific here. I'm just saying there's a whole bunch of stuff, and it's all calling other stuff, and it's not really organized in any sort of sane architecture. So whenever I change anything, I'm afraid I'm going to break something else. So how can I clean this up in a reasonably safe way? So that I end up with something where I've got a much better idea what's going on with my dependencies, and I can build each individual thing independently and safely. And crucially, that I can break up all the deployment routines for all the different bits. I don't want to have to deploy this whole thing in a single routine at once. I want to be able to break up the changes from this bit to the changes from that bit so that each thing can deploy independently and manage its own safety. Well, the first thing that I'm going to do is I'm going to introduce some sort of proxy at the top. I want to capture everything that's calling this thing anywhere in this big mess of stuff. I want to capture it and I want to redirect it. Using a proxy, using like an HTTP proxy or something is a really handy way to do that, because suddenly I can begin to get a good idea of what sort of traffic is coming through and where it's being redirected to. At this stage, I'm not trying to make any changes to the system at all, other than just putting a proxy that's going to receive every single message and send out exactly the same message again. We're just intercepting it and passing it straight on. We're not trying to do anything more than that at this stage. And the reason for that is because, honestly, moving to a more loosely coupled system is going to put a lot more pressure on your network. And we want to know that you can handle it. So let's start with baby steps. If you do this, we raise the amount of pain in your network. If your network starts falling over, well, before you go any further, you need to invest in your network. The next thing that we're going to do is we're going to look for a nice candidate for something to try and separate out of it. And I'm looking at this application down here on the right-hand side. This looks reasonably self-contained. So what we can do is we can build out on completely separate architecture, somewhere completely different. We can build a new version of this app. It might just be a carbon copy of the code, or I might rewrite it in modern software languages or whatever. But the point is that I'm going to build a new version of this bit of it on its own infrastructure somewhere that can be managed independently. At this stage, it's still calling back to the same database. We'll get to that. We do want it to hide its own data, but we'll get to that one step at a time. The next thing that we can do, remember green-blue deployments, clever load balancing tricks? We can just ask our proxy to point all the traffic destined for that application to the new app. And now this app is being managed through the proxy, and all of that traffic is being captured, and we're doing different stuff with it. We're managing where that's going to go. And we can now start, the people who are deploying this application are now nicely, hopefully, separated from everybody else. Once this is done, we can delete the old app, and then hopefully we can move the data across. For a period of time, we might end up with two databases where we're updating both of them just in case. We don't want to end up breaking any other dependencies that we've missed. And eventually we turn off the old database, and we've now got a nice isolated service that is decoupled from everybody else. It can be deployed independently. They can manage their own infrastructure. They can manage their own release cadences. And the monolith itself has just become that little bit simpler. We're chipping away at it bit by bit. What if our application is buried deep within the monolith and it's receiving all sorts of internal calls? What if it's some submodule within some larger runtime somewhere else? Well, what we can do there is we can create some sort of, so here, for example, what we can do is we can create some sort of abstraction layer. So maybe we create a module with the same name, and then we rename the old application to application old or something. And we, again, this abstraction layer is basically doing the same thing that the proxy did. It's just capturing all the traffic, passing it all straight on. We can then repeat our trick by rebuilding a new version of the application somewhere else, using our extraction layer to point to the new version when we're ready. We can possibly be running it in the background through some sort of dark launch scenario. And we can clean up the old one, and we can begin to move our data across. Now, some of the data might be easy. Some of it might be harder. And here, by the way, I've used 3 different databases. These might be 3 databases. They might be 3 database servers. They might all be kind of different schemas within a single database. Different database technologies work differently, so I'm not going to get too hung up on it. But let's say that we still have a dependency between the database that's been brought out and the core database that's left still inside. This isn't ideal. What we would prefer to do is something like this, where all of the data traffic is going back through that proxy, back through that communication layer, and we are avoiding those direct database to database dependencies because they cause us so much pain. If we can do all of the communication through the proxy, through that communication layer, it means that we can understand exactly what our traffic is. We can write tests for what API calls, for what API methods need to be available. We can make sure they're all there. We can make sure they return the right stuff, and so on. It means that we can start to manage our dependencies in a sane way. Of course, this has problems. There will be a performance hit. If you're moving a lot of data about from one database to another, well, maybe these aren't good candidates to be split out into a different service if there's a lot of number crunching going on between them. I mean, there are some things that we can do to solve this problem, such as significantly investing in our network tier, an awful lot of caching. There's all sorts of stuff that we can do that can help. But ultimately, yes, there is going to be a performance hit there. And that is part of the tax that we're going to pay on this architecture. We also need to worry about the integrity of our data. Foreign keys are lovely things, and once we properly hide the data associated with each service from any other service, and we can manage it independently, as much as that gives us huge benefits from a delivery and a safety perspective, we do have to accept that we now don't have anything enforcing our referential integrity. And if your experience is with relational databases, then that might sound difficult and scary and problematic for you. And there are all sorts of reasons, very real concerns that we can have. So, for example, we need to start talking about partitioning, because this is a new problem that we get with distributed systems like this. So let's imagine, for example, we have a shopping cart, a payment gateway, and an inventory. So let's imagine we're your favorite web store, Amazon, ASOS, whatever. You've gone onto your shopping cart, you've bought something. I can pay for it because there's a payment gateway that I can use and that service is running. However, the inventory service is unavailable. I don't know whether I've got the thing in stock. Do you sell the product? Well, if you're some people would say yes, some people would say no. It depends on the scenario. The vast majority of retailers would say yes, sell it anyway, because if they don't, they're going to be losing a lot of money, and it's a lot easier to send an apology email than to lose the business. But in some scenarios, you might not do it. If it's a ludicrously expensive item, or if there's likely to be significant downsides to not selling the item, to selling the item and inappropriately, then maybe you wouldn't. You need to start having these discussions. But the point is, we need to acknowledge that this can happen, and we need to have conversations about what to do in the scenarios where we do have a partition, where we don't have access to all of the data. We need to design resilience into our system, and we're not trying to build robust systems where this never happens. We're accepting that this happens sometimes. And from the ground up, we're embracing a philosophy of resilience where stuff can go wrong. We will deal with it and we'll figure out what the failure conditions are and we'll hopefully automate most of those away. So you do need to make a decision. I've been banging on about more loosely coupled systems for a while, and I've deliberately tried to avoid using the term microservices because that implies that everything needs to be as small and granular, as tiny as it can possibly be. There are very real problems with this, and we need to be honest and open about them. However, the problems with the kind of big ball of mud approach that so many of us have had before is also significant. And which path are you going to go down? You need to make your own call. But I suggest that for most of us, we could afford significantly more coupling than we have right now. And our lives would be an awful lot better if we were dealing with smaller databases that were more contained and where our dependencies were better architected and easier to test. That's all I have for you. So in summary, last time we talked about resilience, we talked about continuous integration, we talked about loose coupling, and this time I've talked about how we can self-service your development environments, make that quick and easy to enable disposable dev environments where we can work on small changes, commit them, and off they go. We've talked about designing for safe deployments. We've talked about deployment patterns that enable you to make changes in a way where we can try and take as much of the risk out of this change as possible. We're not saying that we're never going to have a mistake. What we are saying is that when we make mistakes, we will catch it and we will deal with it in a way that doesn't create a huge amount of pain. And if at all possible, we're going to try and break down our monolith into smaller, more loosely coupled services, just because that helps everything move along much, much more easily. And that's all I have for you. I hope that's been useful. Any questions?
Okay, Alex, thank you so much for that. That was really great. So just a question. You talked about safe deployment patterns, and you also talked about zero downtime. It feels to me like deploying while the system is running is generally more risky, not less risky. Can you explain the connection between safety and zero downtime?
Yeah, maybe I did skip over that a bit quickly. Apologies if I did. So when a change requires a downtime window, that comes with a lot of baggage. It means you probably have to request it from a bunch of people because people don't tend to like their systems turning off very often. You probably need to plan it in advance. You've only got a limited amount of time to put this release together. So it's clearly not something you're going to do in lots of small bits. It's clearly going to happen all at once. So we're going to end up with a big bang release. And also the kind of expand, contract, evolutionary database change philosophy is based on making lots of small changes, each one of them being individually rollbackable, even if the whole end-to-end process isn't. If I was forced to do everything in one downtime window, I would be forced to go through the entire change in one go, turn the system back on, and then discover that I've broken something. So if I can develop a release process where I can release live, because no one change does carry a huge amount of risk, then it means that I can iterate over it much more frequent changes. I guess it also just frames the it just frames what we should be trying to do in our deployments. If we're deploying 10 times a day with a fairly lightweight change review approval process, then I should be making sure that the changes I'm making are really safe changes that hopefully aren't going to cause any harm. And if they do cause harm, I can roll back each change very, very quickly so that hopefully I've mitigated any issues. I hope that helps clarify why I think there's such a strong relationship between zero downtime database releases and safe database releases. Basically, it enables you to do it quickly and fast and frequently.
Awesome. Thank you so much for that. You focused on SQL Server there, and I had a look at Spawn, and that looks really awesome. But does Spawn work for other database platforms as well?
Yeah, I apologize. I may have forgotten to say at the beginning, my history is mostly with SQL Server. So most of today's session was generally based on relational database thinking and specifically SQL Server. That said, Spawn does support a whole bunch of different database platforms. It supports MySQL, Postgres, MariaDB, Mongo, one or two others. If you go to the Spawn website and look for the documentation, it's all detailed there, the platforms that it does support. It doesn't support all the platforms, but it supports a fair few of them.
Awesome. Thank you so much, Alex. You mentioned there was some setup involved in your demo. Do you know where we can find instructions so I can have a go at building this myself? And do I need to buy any software licenses?
Good question. Yeah, so the demo itself is on my GitHub. It's available. It's a public GitHub repo. So if you look for github.com/Alex-Yates, that's my GitHub. And the repo itself is called safe-schema-updates-demo. So if you just go to repositories, it's the most recent one. Yeah, there you are, the safe schema updates one. And there we go. So yeah, you've got all the instructions there. I could probably do with go back and actually reviewing my instructions to make sure they all make sense. But basically, what you need to do is you need to set up a Windows tentacle for your Octopus instance. And the demo I did today, by the way, I used the cloud instance. I set up a free trial of that community edition. And so I did it using the free edition of Octopus. Spawn itself has a free tier. It's useful for playing around, but if you want to use it, start using it for real as part of a company, you're going to end up having to pay something for it. It's not too pricey though. You're going to want to set up an Octopus tentacle on which you'll install the Spawn command line tool and the dbup DLLs. And yeah, that's about it. You need to save an API key in Octopus deploy and save that as a variable called API key. And the easiest way to reference the code is to reference GitHub as a feed in Octopus deploy. If you just Google setting up Octopus deploy the feed, I think I've even included the link there, so you can find the instructions, the official Octopus deploy documentation for setting it up. It's really handy actually. This is the first time I've used the GitHub as a package feed, and it just made so much sense. I'm looking back and I'm thinking, why have I been messing around building my NuGet packages and figuring out all my GitHub actions and stuff to build all my NuGet packages when I can just reference the GitHub repo directly? And all I then need to do is create a tag when I've got a version that I want to build of Octopus deploy. It just works really nicely.
Awesome. Thank you so much. Last question I have, unless anyone has any other questions we want to put to Alex. Do you have or recommend any resources for learning more about loose coupling, deployment patterns, database provisions, etc.?
There's a whole bunch there. I am a bit of a bookworm. I like reading all the books. For loose coupling, there are a couple I can think of. So one of them is Sam Newman's microservices book. That's really good. And any of the domain-driven design books. So there's a distilled one by Vaughan Vernon. And there's a bigger, heavier one that is quite dense, but both of those are very good. I'll go for the distilled one at first because it's much easier to read and gives you a nice first step into domain-driven design and loose coupling. What was the other things he said? So there was loose coupling and
deployment patterns and database provision.
Yeah, okay, deployment patterns. The DevOps Handbook is a very good place to start on that. That gives you a whole bunch of stuff about deployment patterns, especially all the zero downtime type stuff. Refactoring databases by Pramod Sudalaj and Scott Ambler. That's a really good one for all the database kind of evolutionary database design, expand, contract stuff. So that's a good one. And I think you mentioned provisioning as well. There's less stuff out there about provisioning. I did a session at SQL Bits earlier this year with Sander Stead, who is the maintainer of DBA Clone, which is the open source SQL Server provisioning tool that uses all the VHD stuff. So check that out. It's called Solving the DevDB Problem with Docker and DBA Clone. So as I say, I did that with Sander Stead earlier this year at SQL Bits. Yeah, I think that's probably the DBA clone wiki has got some stuff on there as well. If you like your PowerShell and you want to do this SQL Server, so that's quite good. Other than that, I guess just check out the Spawn website and go from there. Probably the folks at Redgate can help you a bit if you ask for their help.
Thank you so much, Alex. So what we also have is a question from an anonymous attendee who missed the first 15 minutes. We'll be emailing you a recording of the full webinar on Friday. Probably be Friday morning, so please do check that out. On that note, that is the end of today's session. We do have some resources for you. If you have a problem with Octopus, reach out to support@octopus.com. They'll normally come back to you within 2 hours. If you have any questions around licensing, you can get us on sales@octopus.com or customer success@octopus.com. If you have a question about how do I do X with Octopus, you can get in touch with our customer solutions team at advice@octopus.com. We do have, at the moment, I think we've got over 50 webinars on our YouTube channel, so please check out youtube.com/Octopus Deploy. We stream all of our webinars there as well. And I hate to ask you this, but please do smash that subscribe button. We've got some really great content, and we're hiring. So we are hiring in the UK, the US, New Zealand, and Australia. So if it is something that you're interested in, please check out octopus.com/company and careers. And definitely check out Alex's blog. This is off the back of an 8-part blog series, and the last one will be going live in the next week or so. That honestly has been instrumental in understanding more about database DevOps, and it's definitely helped me, and I think it'll probably help you as well. Okay, so just a big thank you to Alex for the content. This was a really great webinar. I really enjoyed it, and I learned a bunch as well.
Thank you very, very much for having me. I've enjoyed the experience. It's always a pleasure.
Awesome. Thank you so much, Alex. And also, thank you so much for attending, everyone. A recording will be emailed to you probably on Friday morning in the UK, probably Friday through the evening if you're coming in from the US. We are back on December 15th and 16th with Sarah Lean and Trish Koo as we're talking remote engineering management at Octopus Deploy. And we're starting to book our webinars for 2022. So thank you so much to everyone for coming along. Enjoy the rest of your day, and I'll see you soon.
All the best. See you, folks.